Hi everybody, my name is Christopher Collison, and today we're going to be talking about the importance of communication as a scientist. Let's take a look. So welcome to Graduate Chemistry Writing. CHEM 670 is the course number. My name is Dr. Christopher Collison. And here's the outline for this extended lecture, which will be broken up into parts. First, I'm going to provide an introduction to the goals of the course. I'm going to talk about research and the Masters of Science program in chemistry. I'm going to talk about reading papers and the importance of reading papers. And we're going to get to an end point in this full presentation where we think about quality in writing. And the point here is that you all know what good quality writing is. So let's have a look first at the goals of the course. So this particular course is a 1 credit hour course designed to help you develop skills that will help you communicate your scientific results. More specifically, I'm looking to teach you how to be a better scientific communicator. I pause when I say teach you because ultimately we have to think of the motivations to become a better scientific communicator. When we write, we communicate our own value, and I want for you to recognize the importance of communicating your own value. I hope that you will readily learn the material and will go up the learning curve through your experiences in writing in this course. The other thing we're going to do in this course is you're going to write the introduction to your thesis, to your master's thesis, or you're going to write the introduction to your formal research report for the project-based master's program that you may be in. So we'll add to this, but for now, let's keep it simple. And we're going to talk for a second about what a scientist does. So a scientist will create knowledge, and that scientist may create knowledge by writing, by speaking. Where do we write? How do we communicate what we understand to the wider world? We typically use journal articles, patents, books. We may write blogs, or we might store information on websites. And we also may speak at conferences and seminars and courses. The idea is that we disseminate our understanding. And these days we're doing a lot of work with video, right? So this ends up being a video that I'm doing right now. So it's a hybrid form. So let's answer this question: where are the results communicated? And so here's where we can go to the literature to start to understand something, to try to collect our ideas on what has already been done. And we often say we stand on the shoulders of giants in the scientific world because we're basing all our efforts on other efforts from other people that have come before us. So where have they presented their work? Well, they presented their work largely in journal articles. This is a primary source of information. It's the direct way where scientists communicate the results of their experiments. Often books and review articles are written to summarize those journal articles, and that's why we would say this is a secondary form. The other thing we want to do is we want to ask questions of the quality of the journals and the quality of the science that we're reading, and that is described through something called the impact factor. And how is the impact factor calculated? So the impact factor for a journal describes the number of citations for any single journal article within that publication. It's actually an average. So if you take the total over a course of a year, the total number of citations for all the journal articles in a particular journal, divide that by the number of journal articles that there are, that's how you arrive at the impact factor. And so that's important. We also have a way of understanding the quality of a particular author, and that's called the H-index. And the H-index is best described through the diagram that's shown on the right-hand side in here. So the H-index is basically a number, and this number ends up being, supposing I have 36 publications out there, and 15 of those publications have 15 citations or more, then my H index number will be 15. So here's the number of papers on the x-axis that a particular author may have, and here's the number of citations on the y-axis that author will have for each of those papers. So you can see that for earlier papers for a particular author, there will naturally be more citations than the later papers that they publish, and it's this intersection here, the number of papers that have a certain number of citations, and my example given earlier, think about that. But the H index, the higher it is, the more accomplished the author is in general. Where do we find all the literature that we're interested in looking through? If we want to understand more about our project, we might use something called SciFinder. It's a very powerful tool within the chemical sciences, and we will have some classes to look at SciFinder later in the semester. For now, what we can do is we can sort. For example, here are some of my papers, and these are papers we can see within the last few years, 2019, 2016, 2019, and we can start to see the number of citations that there are. So 16 citations, 12 and 5 in here, and so we can sort those papers by citation, number of citations. That tells us something about, again, the quality and how well these papers are received by the scientific community. And so we'll talk more about that later, and we can also get direct access to these papers. Once we do a search, we can get direct access to these papers through SciFinder. The link to SciFinder is shown at the bottom here. If you do a search for SciFinder and RIT Wallace library, then you'll find the link, and I advise you to, as soon as possible, get access to this particular search tool. Google Scholar also works well, and we'll talk about how you get access to these papers through your RIT email account. Let's talk for a little bit about research and the MS program in chemistry. In particular, when we think about research, and before we start writing our introduction to our thesis, what we're going to think about here is what aspects of research are important. There's a cycle of research. We'll talk shortly about the importance of critical thinking and interpretation. So critical thinking is really about questioning everything, and that's what we do as scientists. We'll also talk about intellectual merit and broad impact. So if we want to do high quality science, we have to think about the intellectual merit and the broad impact, the impact of that work to the world at large. We need to manage expectations. So we also have an opportunity to ask the question, will scientific research ever be complete? So many of you have completed an experiment in your lives already, and you will know that as a result of completing that experiment, the work's not actually done. What comes next? Well, there's always more questions. Okay, so those questions might be, how might we improve the experiment? You start to learn a little bit about the system you're studying, but then you start to peel off the onion skin layers, start to understand more about the system, but you have more and more questions. So I think that's the key to this particular slide. There's always more questions. So let's explore this a little bit further. So what's the difference between results and interpretation? So we may run an experiment, we may get some data. What do we do with that data? So I wanted to give you a few pointers as to the difference between data and interpretation. As a scientist, we communicate our understanding, we create knowledge in the world around us. So let's look at a very recent example. If we start to think about the COVID-19 pandemic and RIT being in Monroe County, a few days ago I went onto the website at the Democrat and Chronicle, the local newspaper, and I found that there were in fact 18 new confirmed cases of COVID-19 since the last update the day before. There's this wonderful breakdown, the number of people and their ages. So this is a data point. So there are 18 new confirmed cases. What do we do with that data point? What is its meaning? How should we make a decision based on this particular data point? Well, I wanted to describe the difference here between an individual data point and some trends in here. So if we look at the data point, so there are 18 new cases in here around this time. Okay, what we can also do is start to look at the number of new cases that there have always been, so day by day, going back through, and in this case we go back through March 2020. And in this particular diagram, so the new cases are very hard to see. They're down here in yellow. There's a very low number of cases at the bottom here. We also have these blue bars. These are the number of tests that there have been on any particular day. And then the yellow line in here ends up being the number of the percentage of those tests that have been positive. And so we can start to actually understand a little bit more when we look at all of this data in its entirety. We can start to look at the trends. Well, if we look at the trends, there's more and more testing as time goes by. Another look at the trend is that we've got this big peak over at the beginning here when the lockdown took place in New York State. So there are a lot of positive tests per number of tests taken, but we also start to see that this number goes down. What we can also see is that the number of positives in Monroe County pretty much stays flat, actually, if you zoom in a little closer. So what we find here is that total number that we're testing positive. It's when we put a data point in amongst many data points that we can start to recognize a trend, and we can perhaps start to inform ourselves as to what's important, right? These numbers aren't going up tremendously. It seems that in New York State and in Monroe County that things are more or less under control, but we have to take things seriously. We have to keep wearing masks. So it's when we look at this data in its entirety that we can start to make better decisions. And my point here is that any one data point is fairly useless. When we add all those data points together, when we start to look at the trends, when we start to explain the data, we can provide an interpretation and we can create some knowledge in the world around us as to how that data might be used. So that's the difference between results and interpretation. I've tried to express how there's an interpretation, and that's the conclusion usually in the paper that we will be communicating. The next question I'm going to ask is, how effective was the experiment? And another thing that we're going to talk about often, certainly as it comes to writing up the introduction to your work, do you have a hypothesis to test? And so when we've completed an experiment, we often want to ask ourselves also, does the hypothesis need to be refined? In this course, you will end up writing your own hypothesis for the work that you're going to do during your master's education at RIT. So what we're going to do is spend some time looking at a particular example, and I'm going to suggest that you go and watch another video, a very simple video about determining the energy in a peanut. If you do a search for energy in a peanut and you plug in the link below, you can go and watch this particular video, and we'll consider what happened in our next follow-up video associated with this course. So see you shortly. I will return.